Hello guys, good evening. How are you doing?
Hi.
Hi, how are you? Good evening. Okay guys, so let's start with the class and then we start moving and talking about, sorry, what I'm doing. So let me start by sharing my screen. Perfect. Do you see my screen, right? Guys, you see it?
Yes.
Excellent. So guys, remember that what we have covered half last class and this class is not included in the midterm, okay? So, but let's continue because we don't have a lot of time in what is left of November and part of December, guys. So I think we were talking, not sure if we finished that, but we were talking about capital allocation, right? Can you confirm that, please? I think.
Yes.
Perfect. So we were talking about capital allocation. What is capital allocation, guys? This is the simplest way of understanding a portfolio. No, normally this part here is done by non-professionals. So non-professionals, I mean people that is not, I'm sorry, people that is not in the field of investments, no? Professional, what I'm writing. Yikes. Non-professional investors. Okay, so who are these guys? Are basically, you know, people that is saving for their pensions, for the retirement. And what they see basically is only two things. No, they see a risky portfolio, and they see something that is more risk-free asset. Okay, makes sense. And in risky portfolio, guys, they don't have a clue what is inside. Okay, inside can be stocks, can be options, can be commodities, can be derivatives, can be whatever. But at this point, we simply ignore this composition. We know that it's a risky portfolio, and that's all what we know. Got it? And I think that I told you that the only way to balance your risk, if you want to be more risk averse, what you do is you put more money in the risk-free component, right? If you want to be a little more risk lower, you move more money into the risky portfolio. That's it. That's what you do. That's the only way you can balance your risk profile. So let's assume, guys, I don't know where in the mathematics we're right, guys, but we have done some math already, but in any case, I will do this very quickly. So why is the percentage invested in risky portfolio? Okay, so risky portfolio, we'll call it portfolio P. Okay, then I have my expected return of my risky portfolio. This is my expected return of risky portfolio. We'll have my risk-free. So remember, the expectation of risk-free is exactly the risk-free because it's a constant. So this is my risk-free portfolio or asset, if you want. I think that with this, I can define everything. Now, what I will define is my complete portfolio. So that's why I'm using C. So this is the expected return of my complete portfolio. Okay, so what is a complete portfolio? Is basically the portfolio that is made of the risky portfolio plus the risk-free instrument. So this is my complete portfolio. Make sense? And then, guys, what is interesting, what we are going to be doing in capital allocation, security, and asset allocation is we're going to be working in something that is called the mean variance portfolio model. So that the thing that implies is that in order to understand this model, I need to have my mean and I need to have my variance. But sometimes instead of the variance, what we are going to use is the volatility. And what is the volatility, guys? Is simply the standard deviation. Okay, so we don't work the variance, we use the standard deviation. Got it? And so from here, I think we decided and we constructed, first of all, I need to know what is my expected return. My expected return, guys, is simply a linear combination of the risk-free, I'm sorry, I would say Y, the percentage I invest in the risky portfolio, expected return in my portfolio, in my risky portfolio, plus 1 minus Y, my risk-free, correct? So this is what I expect to make when I invest in a risky portfolio and the risk-free asset. So if I do some math here, guys, you're going to have another equation that is more common. So this is going to be equal to RF plus Y, expected return of my risky portfolio minus my risk-free. Okay, how do we call this one here? I think I mentioned this already. How do we call this one here? Do you remember? Guys, do you remember? How do we call this ERP, the expected return of my risky portfolio minus
the risk premium?
This is my risk premium. Okay, and this equation here, guys, is basically one of my main equations. So I already derived the mean part of the equation. Got it? Now, the second part of the equation, so let's call this one as 1. What is the second part of my equation? And we're going to be doing this, guys, every single time. So when we go to asset allocation, we're going to do the same. Security allocation, we're going to do the same, a little more complex computation, but that's all. So the second part, guys, is simply how do I compute the variance of my complete portfolio? I will call it variance of C. So the variance of my complete portfolio, or what I will call it, sigma square of C. Got it? And this one here is simply, guys, the variance of Y expected return risky portfolio, comma, 1 minus Y risk-free. And what is interesting here, guys, is you're going to see everything's going, not everything, but almost everything is going to cancel out. So this is going to be Y square variance on my risky portfolio plus 1 minus Y square variance of the risk-free portfolio plus 2 times Y minus Y covariance of what is that? Covariance of my risky portfolio and my risk-free portfolio. Do you remember? And here, this is what I was telling to you guys. What is the variance of a constant?
0.
0. So this part disappears. What is the covariance of a constant with something that changes? A constant with a variable?
Variable.
Nope, 0.
Oh.
Remember that it doesn't matter. Remember what is a covariance, guys? It simply measures the linear dependence. So if you have a positive covariance or correlation, we're going to work with that. If the variable, if this one increases, if it's positive, if this increases, this increases. If it's negative, if this decreases, this increases. Got it? But when you have a constant with a variable, the covariance between them is 0. So no matter what happens with the risk-free can be any number. The risky portfolio can be up, down, whatever. So it's independent of risk-free. So basically, this part also disappears. So finally, guys, what we can argue, and we derive this one here, is simply, and I will call this part here the variance of RP, variance of RP. Now, if I simplify, remember this is the volatility, this is the variance. I want the volatility, square root of everything is going to be this one here. So this is my second equation. Okay, so guys, I have my mean and I have my variance. So basically, I can start building everything here from these two equations. Now, I need to provide you an additional insight here, guys. I will do the following graph. I will do the following graph. Here, I will measure the standard deviation, the volatility of the complete portfolio. And here, what I will measure is the expected return of my complete portfolio. So below, in the y-axis, my risk-free is going to be this one here. And I will say that my expected return of my risky portfolio is going to be here. Make sense? So what is the volatility of the risk-free? Is 0. What is the volatility of the portfolio? Is going to be what we call sigma p. It's a number. So if we cross these 2 points, so I have 1 point here, and I have another point here. If I join these 2 points here, guys, oopsie, this should go crossing this point here. This line here is what is known as a capital allocation line. Make sense? So something that is really important from this graph, guys, you follow me. This part here is sigma p, correct? It's a standard deviation. So from here to here is a standard deviation, sigma p. This part here is simply the expected return of risky portfolio minus my risk-free portfolio. So this is my risk premium. What is the slope? What is the slope of this equation, of this line, guys? S equals what? S equals what? So remember, guys, the slope of the line is simply the tangent of alpha. So it's going to be the opposite side divided by the concurrent side. So S, guys, is going to be equal to ERP minus risk-free over sigma p. Do you know why this is called S? Do you recognize this formula, some of you? Do you recognize this formula? No? No matter. This is the famous, guys, Sharpe ratio. Right? Ratio. Yeah. This is the Sharpe ratio. So what the Sharpe ratio measures is simply the risk premium, because remember the upper part is risk premium, per unit of risk. So that's the definition of Sharpe ratio. The risk premium per unit of risk. Now, what is better, a higher Sharpe ratio or a lower Sharpe ratio, guys? What is better? So do you want to have a small Sharpe ratio or you want to have a large Sharpe ratio?
Small one. Wait.
So remember, this is good, no? The Sharpe ratio is a good thing because what you want is to maximize your
You want
the bigger, the larger. Exactly, exactly. Better the larger one. Okay, so this means the following, guys. How S can be how S can be larger? When the upper side, the numerator is larger, or when the denominator is larger. You see? So I can have the same risk premium, but my risk is very small. So all this S is going to increase. And remember, this measures the units of risk premium. That is this is a payoff, a positive payoff, hopefully, divided by units of risk. So the larger is, the better. Okay, so it means that if the slope is larger and larger and larger, so this implies that we are in a better prospect. Make sense to everyone? Guys?
Yes.
Yeah.
Okay, perfect. So you know what? Before moving, let's put some numbers here. Oh, 1 second only. 1 second. Let me finish this idea, and then we're going to have enough formulas to put some numbers on them. So take a look, guys, of what happens. I will use 1. Yeah, I will use 1 and 2. Okay, so can you note that from here, y equals sigma c over sigma p, correct? I can call this 2a. Do you agree with me, guys? I simply consider y as a function of sigma c, sigma p. Okay, so now what I will do is I will rewrite 1. So I can rewrite 1 in the following way. Equals rf plus, so 1, sorry, it should be 2a in 1. So y equals sigma c over sigma p that multiplies ERP minus RF. So if I reorganize this one here, this is RF plus ERP minus RF divided by sigma p, all these times sigma c. Correct, guys? How do we know this one here? What is this one here? S. So basically, guys, another way of writing this one is simply this one here. Okay, sometimes you're gonna find this formula. It doesn't matter. You should understand what this formula is about. Okay. So now let's do some examples, just to understand how this works. So let's do the examples. So let's assume the following, guys. So I will do some common stuff. So assume that the expected return of my risky portfolio equals 15%. Let's assume that the variance of my volatility of my risky portfolio equals 22%. Let's assume that my risk-free equals 7%. Got it? So for a time being, assume that I want to invest 50-50. Okay, 50-50. So my question is the following. If you invest 50-50, what is the expected return of your complete portfolio? What is the variance of your or volatility of your complete portfolio given this 50-50? Okay, now one thing, the guys, that we don't use fractions. So 15% we use 15, 22 we use 22, 7 we use 7. Okay, so we don't use 0.07, we don't use 0.22. Simply use these numbers so your responses are going to be in terms of percentages directly. Make sense to everyone? Okay, can you please compute these values? You have all the formulas.
Sorry, could you ask the question again? I lost you for a second.
Yeah, my question is, given these values here, given these numbers, so I know that the risky portfolio produces 15%, the volatility of the risky portfolio is 22%, the risk-free equals 7%, and I want to invest 50-50. So this implies 50% in my how do you call it, in my risky portfolio and 50% in my risk-free portfolio. Given this information here, can you tell me what is your expected return of your complete portfolio, basically the mixture of the risky portfolio and the risk-free? And what is the volatility of your complete portfolio, and what is your Sharpe ratio? Can you please compute that? Okay, 1 minute to do that, guys. It's very simple. Ready, guys? Guys, this is very cool because if you have a portfolio investment, even though you are non-professional guys in the future want to do your investments in the for your pension funds or retirement plans, so you can create this information here, guys, expectations, etc. If you go, for example, to TIAA-CREF or other pension fund, big pension fund, they provide you insights about all these values here. So you can basically just fill the information and then try to see, where do you feel comfortable? Is 50-50, it is more, etc. I will show you in a minute. Okay. You done? Okay, guys, you tell me. So how do I compute? I have all the information for computing the mean and the variance, correct? So what is my risk-free? Well, I can use this one here. My risk-free is going to be 7 plus my y is given. So I will show you how to find this y in a minute, 0.5. And 15 minus 7. Correct, guys?
Yes.
So
Yes.
what do you get?
11.
11%. So guys, if you decide to invest 50% of your money in the risky portfolio and the remaining part in the risk-free portfolio, you're going to get, in average, you're going to get 11%. Got it? Now, what is the variance of this one here? The variance is simply proportional to the volatility of the, sorry, not the variance, the volatility of your complete portfolio is proportional to your weight in the risky portfolio times the variance of the risky portfolio. So in this case, my weight is 0.5 and my variance is 22. So in this case, I have 11%. Now, what is my S? Well, I have my Sharpe ratio is going to be equal to 15 minus 7 over 11, correct? So what do you get here? Someone? 8 divided by 11.
0.36.
0.36. Okay. And that's it. So let's do more examples, and you help me, please.
Sorry, Prof. Is
Yep.
it 11? Is it 11 or 22 in the denominator?
Oh, yeah.
Where? Oh, here
RDS, yeah.
is this one
Oh,
here.
70.
Is this one here?
Okay.
Is this one here? Good catch, man. So what is this one then?
No, it's still 0.36.
Oh, it's 0.036. Yes, it is 22. I'm using the sigma p, guys. Correct. Okay. So I want a couple of more examples based basically on the same. So we continue with the same. So we continue with the same example, but now assume that y equals 1. And third case, assume that y equals 1.4 or 1.5. Please compute again what is my expected return of my complete portfolio, what is the variance, and what is my Sharpe ratio. Okay, and the same here, what is the expected return of my complete portfolio, what is my variance, and what is my Sharpe ratio.
Dr. Nifo.
Yes, Daniel.
Sorry, why is the
Proportion
For-
of your investment money in the risky portfolio.
proportion
Yes, percentage.
percentage? So
Yes. So if you have $100,
so
for
can
example,
it so
to
can
invest,
it be 1.5?
yeah, that's a beauty. This is what I will explain this in a minute.
Like you get more money? Because like I assume
Yeah,
one is the max.
exactly. No. I will explain you in a minute. This is when you work well. Indeed, if you are a regular individual, non-professional individual, yes, the maximum can be 1. But in real
Or
life,
are you leveraging here or something?
yes, exactly.
Oh, I
Exactly
see.
that.
All
Exactly
right.
that.
Okay, I get it. Okay.
Yep.
Thanks.
Okay. So 1 minute, guys, and then we estimate the values.
Professor, but either way here, y equals 1 means just 100%, right? Just
100%,
100%
goes, all your money goes to the risky portfolio,
okay.
basically, and 0 goes to the risk-free portfolio.
Mhm.
Okay. And then I will do a graph here to explain you why I'm doing this. Just help me with the numbers. I will be copying here. So this is 7. Okay, so obviously here is going to be 15%, correct? Here is going to be 22%. And you can see, guys, the Sharpe ratio doesn't change, 0.36. Now, if you go here, what do you get here? 8, 12, 19?
Yes, I got
Yes.
19.
Yeah, 19. And what about this one here?
33.
33.
33, and the Sharpe ratio doesn't change. Okay, so now let's do all the points in this graph here. And we're going to be using this graph all the time, guys. So this is my sigma complete. This is my expected return complete. Then I have here, this is 7. This is 15, correct? So for 7 corresponds 0% risk. For 15, it is 22. So let me draw this. And then if I join these two lines, I obtain my capital allocation line. Okay, so this is my capital allocation line. What is interesting is the following, guys. When we decided to invest 50%, so I will be more or less here, I will be at 11. This is gonna give me, I will be here, and I will obtain 11% also in returns. Make sense? Then if I go into the 1.5, I will go into 33 here. And I should obtain 19%. Okay, copy this one here, and then we are going to learn a lot of lessons from this graph.
Professor, sorry, what's CAL?
Capital
allocation.
Capital allocation line, exactly. Okay, ready? So a lot of lessons here, guys. Before going to the graph, remember that if y equals 1.5, what happens with 1 minus y? Minus 0.5, correct? Guys, do you agree? When you have
Yes.
a negative, guys, the technical word is you are shorting. Okay, and when the shorting happens in the risk-free, so when this happens with a risk-free instrument, this is called leverage. So basically what this means is the following, guys. You really like the risky portfolio and you want to invest more than what you have. So what you can do is go into the bank, for example, the one that has the risk-free interest rate, get a loan, and invest this loan in the risky portfolio. Got it? So this is the idea of shorting, and if we're talking about the risk-free, this is called leverage also. Okay, so now copy, and then we discuss a graph, because from the graph we're going to learn tons of things. So why the capital allocation line is crucial in understanding all the model, guys? Because it basically represents the risk aversion of individuals, you see? So guys, if an extreme risk averse individual, so where do you think he's gonna be? To the left or to the right of this point? So let's call this point P. To the left, right? Agree with me?
Yeah, lower the.
Obviously. So what you do is risk aversion implies that you are going to try to decrease your volatility. But remember, guys, in economics, there is a law. That is, the more risk, more rewards. The less the risk, the less the rewards. Make sense? Okay. So a completely risk-averse individual, where is he going to be located? Okay, well, he's going to have his money in the bank. That's it. You know, secured, insured. I don't care to make less money or very few money, but I'm sure that nothing's going to happen with my money. Completely risk-averse is going to be here. More risk lovers or risk seekers, guys, are going to start moving to this side here. So this is more risk-averse. And this is, sorry, this is less risk-averse. No, sorry, it's okay. More risk-averse and less risk-averse. So less risk-averse implies, guys, that you are willing to, you know, put more money at risk. Got it? And also remember, this one here depends, if you're talking about a pension fund. So this depends on where you are in your life. So if you're just starting your work, 23, 24 years old, you know what? Yeah, why not? Just put it in the game. So perhaps invest around this part here, you know, around 1. But if you are going into the 50s, into the 60s, you need to be more risk averse. So you start moving towards this direction. Because remember, guys, all this is based on probabilities. So your expectation means that in average, you expect this value. Got it? However, given the volatility, guys, you can receive more or you can receive less. Got it? So that's why volatility is crucial. It's going to play a crucial role here later that we're going to start playing. Make sense to you?
Yes.
Yes.
Clear? Perfect. Okay, so we can move then into how. So up to here, guys, is purely mathematics. Do you agree? So it is a complete exercise on numbers. Yes, just the formulas, and then you arrive to the formulas to this point here. Now, the next question is, do I have an optimal Y? So do I have an optimal allocation in the risky portfolio? So guys, if you just take a look to these numbers, what percentage of your portfolio you should put in this portfolio? Imagine that this is the data that you have in real life. Give me a number. How do you feel comfortable? Because remember, guys, that if you go the farther you go to the right, you can make more money. But remember, volatility is there. Volatility can kill you. Okay, you know what? Do you know confidence intervals, guys?
Yeah.
Okay, so you know what? Let me clear something. 1 second. So before understanding this one here, I will do a brief, just briefly. I will do, remember confidence intervals, okay? Just to show you what is the meaning of this 33, this 19, this 15, etc. So I will again start with my expected return of my complete portfolio. For the first case is equal to 11%. My variance of my portfolio, see this was example 1. My variance is, what was my variance? 11%. You agree? So do you remember the confidence interval? What is the input? How do I compute the confidence interval? In general, guys, we say that mu is the population mean, belongs to the sample mean, plus minus, let's say 1.96, let's call it C because we're going to learn that. Let's call this C times square root volatility. Okay, well, it's a rough approximation because you need to divide this by square root of n, but in any case, let's assume that. So what is C, guys? Do you remember C depends on what? The C comes from the standard normal distribution. So let's go to the easy case. We're not going to use T distributions or anything. This is the financial econometrics. A standard normal distribution. Okay. And basically, do you remember how the standard normal distribution looks like? The standard normal distribution, guys, looks like that. It's a bell shape. Oopsie, black. It's ugly, but should be symmetric. Nah, it's my worst normal distribution ever. Yeah, it looks better. It is symmetric. Do you agree? Guys, do you understand the normal distribution? So for this C, guys, the only thing that I need to find is what is my confidence level. Okay, so my confidence level, guys, normally varies between 90%, 95%, and 99%. Right? So what is the idea of this level? So let me take one of them. Let me take 90%. So 90% implies that, no, sorry, 95%. Let's assume 95% is this part here. So this is what we call non-rejection zone. Non-rejection zone. And from here to here, and from here to here is simply rejection zones. Okay, and this C here, guys, are these ones here. This is my minus C, so this is symmetric, and this is my C. And if you go to your tables, guys, the famous values for the, so let me show you my Excel. So let me create, give me 1 second, I will open. And I will show you Excel. So how do you find, imagine that you have, indeed you need a significance level. So 90 is equal to, or 95 is 0.05, correct? Because you work 1 minus the confidence level, so it's 0.05. So what you do here is you do norm inverse. The probability, the mean 0, and the variance 1. So I will copy the same, just with the main values. 0.1, that is 90%. Oh, what is he doing here? $2.32. Wait a second. Why is this doing? Oh. Yes. Okay, guys. How Excel works is the following. So let me explain you in a minute. First, let's go to my whiteboard again. So if this is 95%, guys, do you agree? So what is the value? Where's my mouse? What is this value here? This is going to be, this is something that is called alpha over 2. So it's going to be 0.025. Do you agree with me or not? So what is alpha? Alpha, guys, is simply 1 minus the confidence level, in this case, 1 minus 0.95. So alpha equals 0.05. So alpha is known as the significance level. Okay? So what I'm trying to find is these values of X, because I know this one here in terms of my formula, guys, this one here is my X bar, and this one here is my sigma, just to apply to my formula. So the only thing that I need to know is Z. Okay, and C depends on the confidence level. So how confident you want to be sure, you want to be in order to ensure that your expected value falls between these values in a confidence interval. So if you see, guys, if the confidence level is 0.95, okay, so this implies that the extremes are going to be 0.025 and 0.025. You simply go to Excel, and then you can see, you simply write 0.025. 0.025. Yeah. What's going on with my mouse? Oh, here we go. Okay, you simply use this formula, guys. Is equal to norm.inf 0.02501. 0.1 means is a standard normal distribution. The standard normal distribution has a mean of 0 and a standard deviation of 1. So that's why I use 0 and 1. And then I got the confidence intervals. Sorry, the critical values. So these ones here are called critical values. Pasa, Francisco. Toma. No puedo, hijo. Pasa nomás. Pasa nomás, hijo. Acá. Okay. Makes sense to you guys? Do you understand? This is not part of the class. I just want to show you what is the impact of volatility on your decision. So you need to be aware of that. No, mirando hacia mí. Ah, esto sí no me acuerdo. Creo que es así. Está bien, así está. No. Está bien, ahí no hay problema. Está bien. La cosa es que no se mueva, ¿no? Okay, guys, I'm sorry. What I was going to tell you. Yes, okay. So what is the value here? So if I want to replace this one here, guys, when you have these 2 points of information, so your expected return, so this one mu is going to be your confidence interval for your expected returns. Okay, and take a look to what happens. This number is going to belong to 11%, this one, plus minus 1.96, that is your C, times 11%. Okay, so this implies that mu is going to be between 11% plus minus one, plus, let's do plus, Minus, let's do the left, minus 1.96 that multiplies 11%, and 11% plus 1.96 times 11%. Can you please compute this confidence interval? Mu belongs to what and what?
I got negative 10.56
Yep.
and 32.56.
56. Okay. Here's what I want you to understand. When you have this type of portfolios, guys, and you want to be 95% confident that your return, given this market condition, is going to fall between minus 10.5 and 32.56. Someone can verify that? Yeah, I assume, right? Guys, you see that the range? So you can lose 10% or you can make 32%. So this is being 50-50.
Or it could
Agree?
fall or it could fall in between.
You can fall in between. So basically you're going to be 95 confident that you're going to fall in between. So your value should be in between. What is the expected value? In average, what are you going to be making? 11%. But then you can lose up to 10% and you can, you can lose up to, and you can make up to 32%. Got it? So this is where the concept of risk aversion comes, guys. So some of you are going to feel, oh, yeah, okay, I'm okay here, but perhaps I'm not okay here. So how do you reduce your risk aversion? How do I reduce this one? Guys, remember, case one is
decrease the volatility.
no, you cannot decrease volatility, guys. Volatility is given, volatility is the market. The mean is the market. Z is mathematical application. So what is the only way in which I can reduce my risk?
Lower your Y.
Exactly. So I can lower my Y. Got it? Make sense to you? So can you do the same exercise now, but assume Y equals, I will go to the extreme, the number 3. Y equals 1.5. Can you construct that? What is my mu? What is my confidence interval? 1 minute to do this. Guys, you can tell me. 1 more minute, okay? Ready, guys? What do you get? The formula is going to be the same. The only thing is that it changes the values, right? So mu is going to belong to, in the third case I have here, what is my expected return? 19% minus 1.96 that multiplies 33%. Agree with me? So plus minus. So from here, mu belongs to, the first term is going to be 19% minus 1.96 times 33%. And your one is going to be 19% plus 1.96 that multiplies 13%, 33%. So can you give me the values?
Minus 45.68.
Yep.
And then 83.68.
8?
Yep.
Perfect. You can see, guys, if you decide to take more risk, so if you decide to put your money in the risky portfolio, of course you can make much more, but you can lose much more. So this depends on your risk profile. So how risk averse you are. Got it? But that's the concept that you need to understand, guys, that the expected value is simply the middle point. You can be in average 11%, but you know that you can be making or losing 10%. Is it possible at 95% confidence interval, or you can be making 32%? In average, it's 11%. Do you understand this concept?
Professor, I'm
Yes.
sorry, I might have missed something important. Where did this 19% come from?
Which 19? Oh, this one here. Yes, example number 3. This one here. Remember
Oh,
number.
that's what we were using. Oh,
Yeah,
sorry.
yeah.
I was
So,
looking at this exact same example. All right, got
Yeah.
it.
make sense?
Sorry, Prof. Do we use sigma P or sigma C?
Which one? C,
Oh.
sigma C, because I'm talking about the portfolio.
Well,
Sorry, this should be C.
okay.
C is this one here. Is this one. And this one here. So I'm talking basically what is my expected return of my complete portfolio, and what is my confidence interval for my complete portfolio. You see that? So it's of my complete investment, risk-free and your one, risky portfolio. Sí. Ciérralo, por favor. Sí. Ciérralo despacio. Got it, guys? Make sense? Oh, man. Sorry. Esta puerta no se cierra. Voy a poner algo acá atrás, ¿ah? Guys, questions? Nope. Okay, so here we go to a following question, guys. Let me create another one. Okay, so we are basically now in the following situation. This is my sigma C. This is my expected return. Oh, come on. No sé qué pasaba con esta cosa. Siempre se me logra. Oh, perfect, Carlos. Gracias. Okay. Also, and here we have my risk-free. I have my RP, and I will make the graph like that. And I have here my sigma P, correct? So, and this one here is my capital allocation line. So now the next question, guys, is that, you know what, I've been playing with Y manually. I said, okay, what happens if Y is 0.5? What happens if Y equals 1? What happens if Y equals 1.1, right? But there should be an automatic way, an optimized way of finding my optimal portfolio location, okay? My optimal Y star. You know, and this one here depends, guys, on utility functions and basically on preferences, okay? And normally the preferences in this framework, in this environment of sigma C expected return, are going to be something like that. You're familiar with preference curves, right? So the preference curves of the individuals are going to be like that. Better is going up. So basically here I can be better. I can basically be better up to this point here. So what I will be doing is, these are called indifference curves. And always better is going up. Got it? So if I start here, obviously I can improve. So I can start moving up to what point? Up to a point in which the indifference curve is tangent to the capital allocation line. Got it? So this is going to be my optimal Y. I will obtain this point, obtaining my optimal Y. And the mathematics is very simple, guys. So what we try to do is I will try to define a utility function. And my utility function, guys, is going to depend positively on my expected return. So the more my expected return, the more money I make, I feel better. And it's going to be subtracted, and I will explain you why do we use this 0.05a. It's going to be subtracted by the volatility. So volatility for me creates a disutility. So I feel bad the more volatile the markets are. So that's why, guys, if you're not professional traders, you get afraid of volatility. So you know what? You don't like volatility. So if you go intraday and you see the prices moving significantly, you simply move the market because this is not your career. You're not trained to see volatility like that. Make sense to you? So this component here, we use this component here, guys, because we use numbers instead of fractions. So what I mean is the following: 22% is equal to 22. So we use 22. We don't use 0.22. So that's why if it's 22%, now you're going to see in a minute why this 0.05 transforms this 22 into a decimal number. You're going to see in a minute. But the question is, what is this A? Okay, so this A, guys, measure your risk aversion. So this is called the risk aversion coefficient. Okay, so A measures the risk aversion coefficient. And the rule you need to remember, guys, is that the larger, the more risk averse. Now, guys, this value in real life always is between 2 and 6. And the value that is the most used is 4. So basically with a level 4, we can identify a very decent proportion of risk-averse individuals. But if you are really risk-averse, the number is going to go up. If you are less risk-averse, the number is going to go down. If you are risk neutral, guys, A equals 0. Okay, so some note here. If A equals 0, so you are going to be an individual that is a risk neutral individual. Okay, so how do I arrive to a mathematical formula to find this point here? Well, as usual, guys, what do you try to do? What you try to do always, you try to maximize your utility function, correct? What is the only variable that you can, okay, and I will explain, I will write this one in terms of the formula. This one here equals RF plus Y ERP minus risk-free. Do you agree? So the expected return of my complete portfolio is this part here. We have done that just a couple of minutes ago. Minus 0.005 A is a number, and sigma is going to be Y squared sigma squared P. I'm just using, guys, formulas. I think it's formula 1. So this is from formula 1. And I think this one here is formula 2A. No, sorry, formula 2, equation 2. So what is the only variable I can manage here, guys? What is the only variable that I have authority over? I can change. Which one?
A.
Why?
A, guy, is given. Okay,
Why?
A is your risk profile. Exactly. The only variable that you can change is Y. So that's why it's maximized in terms of Y. You cannot change the expected returns. You cannot change the volatility. You cannot change that. That's given by the market. The only thing that you can change, that you can decide on, is basically Y. So that's why the optimization is going to be in terms of Y. Do you remember what was the first order condition for optimization, guys? Do you remember that? The first derivative of the utility function respect to Y should be equal to 0. Correct? So that's what I will do. So sorry, I will divide my screen. It doesn't look very nice, but let's do that. So what I will do is I will take the derivative. Let's call this one, I don't know, perhaps 5. Let's take the first derivative of this respect to Y. So here, so I will say derivative of U respect to Y equals, here we have Y, correct? So the derivative of Y multiply a constant is a constant. So it's going to be expected return of my portfolio minus my risk-free. Okay, I've done this part here. What happens when you have Y squared? Derivative of Y squared multiplying a constant here, the 2 goes down. So you multiply 2 times 0.05 equals 0.01 minus 0.01 A sigma squared P times Y. And I equalize this equal to 0. Make sense to you? Guys, any questions? Okay, now I have only one variable, that is Y, and I will call this Y star. So this is going to be my optimal Y. It's going to be simply equal to, I move this to the other side. It's going to be ERP minus RF divided by 0.01 times A times sigma square of P. So this is your equation, guys. And with this equation, we have finished capital allocation. Okay, let's do one example. Copy, and in one example, you're going to understand. Okay, so let's do the following example, guys. Assume that you have one individual that is, moderate risk averse. So that's why A is closer to 0, A equals 2. And then you have one individual that is more risk averse, A equals 4. Got it? So with this information, guys, I want you to tell me what is the expected, the total allocation on risky portfolio of this individual. What is the expected return of his portfolio? What is the volatility of his portfolio? And what is the Sharpe ratio of his portfolio for individual number 2? And do the same for individual number 4, risk aversion number 4. Okay, guys, 5 minutes to do this stuff. Guys, is clear what you are trying to do? Guys,
Get
yes?
get the
I'm a bit
result.
lost, Professor.
Okay.
But what numbers are we using, for example, for RF?
Oh, the same as before. The previous
So
example. I think it's
previous
7.
example.
Yeah, the previous example, please. The same numbers as before. Okay, 5 minutes to do this.
So ERP equals 15% here, RF equals 7%.
Yes, exactly.
Okay.
And 22, the sigma squared P.
Professor, I have a question. In the formula for Y, optimal Y,
Yes,
so there's sigma p squared.
yes.
So if we had 22% in the example,
22 squared. Simply
22
that,
squared,
remember, that's the beauty about doing this stuff is that the number
it's just simple, yeah.
is squared. Exactly that.
Okay, great, thank you.
Yep. How are we doing, guys?
Professor, I thought the Sharpe ratio, the defined S,
Yes.
that's also wouldn't that remain constant? Like,
Yes.
0.32?
Because remember, yes. Remember, S doesn't depend on the risk aversion coefficient A. It depends only on the risk premium and the volatility. You see? So no matter which, how is your risk aversion, it doesn't matter. S is going to be S always.
So we're not supposed to find it then?
No. Yes. I will ask you just to know that you know how to compute this number. But yes, in real life, you don't need to. Make sense? Guys, make sense?
Yeah.
Yes.
Okay, so let's take a look to, I do one and you tell me the other one, okay? So when A equals 2, so let's do A equals 2. So my Y star, so this is my optimal investment, guys. It's going to be, what was the expected return? 15
15
minus 7. 0.01 times, okay, I will put the 4 at the end, times 22, or no, times 4 times 22 squared, correct? Guys agree?
Yeah, so we're writing the second example, right? Where A is 4.
Yeah, sorry. This is 2. You're completely right, 2. So what do we get? Shh. Lisa and Francisco. Okay. So what do you get here?
8 over 9.68,
And this is equal to
0.83. And that's how much I got.
8.83.
83.
Perfect. So what is the meaning of that? 83% of your wealth, of your investment, is going to be into the risky portfolio. Got it? So basically your graph, well, this is not a good graph, so you're going to be located around here. Correct, guys? You're going to be closer to 1, so closer to your risky portfolio, so you're going to be around here. And now what we need to compute is what is the expected return that corresponds to this value, and what is the volatility that corresponds to this value. Okay, so what I will do is, what is my expected return? Complete portfolio is going to be my 7 plus 0.83, because I have Y already, 15 minus 7. So what do you get here?
13.64.
Perfect. And what is going to be the volatility? Is going to be 0.83 times the volatility of the risky portfolio. This is equal to what?
18.26.
18.26. Great. So basically, guys, what it means is that if you're an individual number 2, you're going to put 83% of your investments in a risky portfolio. Your expected return, so let me change this color. The expected return is going to be, so remember, this is 15. Your expected return is going to be 13.64. And your risk is going to be 18.26. Of course, you can build from here your confidence intervals, etc. Okay, but this is crucial. Make sense to you? Now, what happens with an individual number 4? So now let's do individual number 4. So this guy is, this guy is more risk averse, correct? Agree with me or not? Remember the rule, the higher the number, the more risk averse you are. So the more risk averse you are implies that you're going to be located where? To the right or to the left of the point that we have found?
To the left.
To the left, exactly that. Okay, so let's compute that. So y star is going to be, in this case, 15 minus 7. The only thing that changes is my a, 0.01 times 4 times 22 squared. So what do you get here?
Well, I got it 8 over 19.36, and it's, yeah, it's 0.41.
0.41. Excellent. So if I use 0.41, what I expect is that my expected return of my complete portfolio is going to be 7 plus 0.41, 15 minus 7. And my variance or volatility, sorry, of my complete portfolio is going to be 0.41 times 22. So someone can give you the values?
It's 10.31 for ERC.
Yep.
And 9.02.
902. So this implies, basically, guys, okay, let's assume this one here. So this implies that you're gonna get, if you're more risk averse, this is going to be 9.02. Remember, this is 7. And the risk is going to be 9.02. Got it? So because you are more risk averse, so this is individual 4. And the other one is individual, this guy is individual 2. Guys, make sense to you? Perfect. So next class, we're going to do more. We're going to discuss the Excel file that you need to replicate. Not next class, next class. Okay, questions, guys. So just a brief review about, not review, just talking about the exam.
Oh, Professor, I had a question about the exam. Are
Yes.
we going to compute IRR and others in the Excel?
No, you know what I was thinking, guys. The exam. No. You're not going to compute the IRR, but of course the net present value, etc. Perhaps I will give you the IRR immediately, and then I tell you, guys, if the IRR of this project is this, what is your decision rule? You see that? So that can be part of the exam. Interpretation of the result. Make sense? So the topics, guys, are the same ones as I mentioned. So I will prepare the exam, but I will focus basically on interest rates as usual. Okay, the ones that I mentioned the other week. So interest rates, time transformations. This should be very easy for you. We need to talk about discounts. We should be able to talk about a net present value, net future value, how they are related. Internal rate of return, just remember interpretation. So if the internal rate of return is larger than my opportunity cost, I do this stuff, etc. So, okay, so you're not going to compute this stuff here. Then, of course, we need to talk about bonds. And finally, financial accounting. Okay, so I'm deciding how to do the financial accounting. I think it's going to be by, I will give you as a text, as a part of your exam. And then you should be able to do that in Word. Now, guys, the challenge is that we are via Zoom. So the exam is going to be a regular Zoom. So we start at 5:30, and then we finish. If you can you come let's say at 5:15, so you have an additional longer time.
Yes.
We go at 5, if that's okay with you. More time.
Yeah, if you want 5, is okay with me too.
Okay. I'll be there at 5.
Yeah, no. But wait, we need to be all because I cannot do one exam for.
Ah,
So
Yeah,
can
I
you?
can
I can also be at 5.
Yeah,
you
five.
can do 5, so it's 2-hour exam, 5 to 7.
Yeah, 5. Yeah, 5 to 7. Yes, basically, because remember what happens is that I need to give you at least 15 minutes to scan or take pictures, and be sure that you send me a single PDF, please. So if you take pictures with your camera, be sure that you can ensemble all of them in a single PDF. Got it? And then when you send me your exams, I need to be sure that I can read them. So we do one by one. So if Daniel finishes first, with Daniel, I need to go and see, okay, send me the email and I will check one by one your work. Got it? So it is easy, guys. It's just practice what we have done. If you redo all the examples that we have done and you're able to basically manage them and do them, so you're more than well prepared. There are no surprises here. There are not hidden tricks here. It's simply, I want to be sure that you understand the fundamentals of what we have done. Got it?
Dr. Ngifo, when you say that the financial accounting could be in Word, what do you mean by that?
Basically, what I mean is printed. Do you remember the?
Or like the scanned questions you gave?
Exactly,
Mhm.
exactly that. It should be like that. Or
Oh.
I need to define if you do, or perhaps you do this in Excel directly, it's much simpler. But I need to decide that, guys. I need to prepare the exam, so I will do this weekend. And then by Sunday, I should have a clear picture. And then I can tell you, hey guys, you know what? This part is going to be written, and perhaps the financial accounting is going to be in Excel. So basically, this implies that if the financial accounting is in Excel, you need to send two things. You need to send your exam. So remember, you need to print your exam unless you want to type in Word. That is going to be challenged. The best strategy for you guys is to receive the exam, print the exam, write, handwriting. Once you finish, scan the exam, send me back the exam. Got it? That's the easy thing. If you don't have an scan, please take pictures, but just be sure, please, that the pictures are in a single page, in a single document. Otherwise, it's going to be messy. And if there is Excel, you simply copy your Excel to your exam and then send this back to me, and then we are done. Make sense? Yep.
Yes.
Okay, guys. So study, please study. So if you have questions, I will be reviewing my email. These are crazy days because of elections. I'm part of the investment committee, so we have meetings almost every single day. But just let me know. I'm always around.
Professor, would you have a document of all the exercises we do, just in case I missed one or two?
I don't have them.
You don't have, okay.
Yeah, everything that comes with my mind. I'm sorry, I just create exercises in the fly. So
Okay.
what please, if you can share this way, if you can work in groups, it's more than perfect. If you can share work with ETL, Kagis, or Mariam, Valentina, please feel free to work in groups and share ideas and questions if you have questions. Much better for me if 3 or 2 or a group of you ask me a single question than having 4 emails with the same question. It's much simpler. Got it?
Maybe we can do a Google Docs where we share, I don't know.
Yeah,
like,
definitely.
Like questions and the notes.
Yep.
I don't know if you guys can write in the chat your emails, and then I can create a.
Yeah, you know what I can do for you guys? I can create a how do you call it? A drive, a Google Drive, so you can put whatever you want, or you prefer a Google Doc? No, better you do that. Yes, better you do that. If you need my help, just let me know. I can, you have all the emails of all the group in the Zoom information that I send to everyone every single night.
Okay.
All the email list is there, so you can just copy paste from there.
Okay.
That's a good idea. That's a good idea, guys. Just practice between you. If you have questions, ask yourself, and then you ask me. I'm always around. Okay, guys. So we see you next Wednesday at 5 p.m. Just to be sure. Okay, so you have 2 hours. It's going to be more than enough. You're going to see. You're going to feel more than enough. You're going to feel very comfortable. Just study.
Sorry, one more question, Dr. Ngifo. For
Yeah.
those of us who don't have a printer, is it okay if we write our answers on an exam pad? We can view the question online.
Oh yeah, of course.
Okay.
Of course.
Okay.
That's okay. That's
Okay.
perfect with me.
All right. Thanks so much, Dr. Ngifo.
My pleasure.
Sorry, I'm sorry, I didn't get that. We need to print?
Yes.
don't-
Well, you know what? If the easy, that's what I was telling you. The easy thing for you is to print. Or you can write in Word, or you can use, you see I have like a blackboard here. Your notepad, you can use your notepad or whatever. It
Mhm.
just,
I thought what was gonna happen, for example, in this notebook, I was just gonna the questions will be provided, and then I'll just
Yeah.
write my answers in the notepad. And
Yeah,
then
that's
I'll
perfect.
just take a picture of
Yeah,
that.
that's perfect.
Yeah, that's what
Like-
I'm also.
Yeah,
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 'cause, like,
yeah.
I don't have a
That's
printer.
perfect. Yeah,
Mhm.
guys, that's perfect. That's perfect. The
Good.
only thing is that just be clear, okay? Don't. The tricky part for me is that trying to understand what you have done. Try to understand, and I will give you spaces. So if I give you 5 spaces, guys, you cannot write a page of document. No. Wait. I want you to be concise. I will give you 5 lines, and the maximum you can use is 5 lines. Got it? So if you use your notebook, your whatever, it's 5 lines, 5 lines. Make sense to you? Because sometimes a single question, guys, I don't know why you want to tell me your life in a mathematical question. And so you write 3 pages on a single thing. So wait a second. No, just give me 3, 4 lines. That's what I will do. Got it? Make sense?
Okay.
Okay, guys, perfect. So
One question: where do
yeah.
you think you can find exercises to practice other than the ones that you did in class? Because I think most of the ones you did in class, I wrote down, like, my notes are very broad, not like the examples and the complete exercises aren't in all my notes. So maybe you could like tell me like where we can find like exercises.
That's exactly related to the question of Daniel. Unfortunately, what I do is I do the own exercises, so I create them on the fly. So in that case, Valentina, I really suggest you to look for Mariam or Kagiso or Daniel or ETL. I assume they have better copies, so you can share your notes. But Valentina, that's what I was telling you from the first day. You need to copy as if you are in a class and copy all the details, so you can really go back to your examples and you have the answers, the correct answers. You can redo them and then understand how this works. Please work with your friends because I don't have examples.
Okay.
Okay, if you have questions, please let me know. Of course, more than happy to help you.
And would you say the book is a good source to go to exercises?
For all this part now.
For which one?
For all this part in the first exam now. No, there is in the book doesn't has very little of these concepts. For the second part, yes, the book is going to be very helpful. But for the first part, for this part here that comes into the midterm, guys, it's just the notebook.
The notebook, the notes.
The notes, right. Please join with Mariam, just share information with your colleagues because they should have a copy this one here.
Okay.
Okay, Valentina?
Mhm.
Okay, guys, so we see you in a week then. So study and then good luck, guys. We talk soon. Okay,
Bye. Thanks, Prof.
see you guys. Take
Thank
care.
you, Professor. Goodbye.
Thank you,
My
Professor.
pleasure. Bye-bye. Bye.